Welcome. Let's solve systems using substitution. Here's a little joke. Why did the chef throw the unsolved system of equations out of the restaurant? The menu said no substitution. We're going to use algebra and substitution to solve a system of equations. We will do 4 examples together. Let's get ready. You're going to need paper, pencil, and your calculator, and be sure to take notes from the last slide. Here we're going to try to solve this system using substitution. Here we have 2 equations. They each have 2 variables. All right, what's the plan? Well, if we solve one of the equations for one variable, we can then plug that into the other equation. Really important to be using parentheses. We're going to then solve that equation, plug that answer into one of the equations to find the other variable, and then write our answer as a point. It sounds a little challenging, but we'll get through this. So, if I take a look, I have a 2x, a 3y, an x, and a y. I want to solve by substitution, so I want to solve for either x or y, and I'm going to use the second equation because it doesn't have any coefficients in front of the variables. So I'm going to solve this equation, and I'm going to solve it for x. So x equals, I'm going to subtract y from both sides, and this becomes 5 minus y. So now I'm going to take this equation, which is x, and I'm going to plug it into that x up in the other equation. Always make sure you go into the other equation, and you really need parentheses. So I'm going to have 2, and then my red x, which is 5 minus y, plus 3y equals 12. And you can see what I did. Now I have an equation with just y's in it. So I'm going to do my distributive property and get 10 minus 2y plus 3y equals 12. Notice those y's are on the same side, so I'm going to combine like terms. So negative 2y and plus 3y is just y. And I'm going to subtract 10 from both sides. And I get y to be 2. That's part of my answer. Don't celebrate too early. So I'm going to plug this. I can plug it back into either equation. I'm going to plug it into the second equation just because it has less numbers in it. So I have x plus 2 equals 5. I plugged my 2 in where the y was. I'm going to subtract 2 over, and I get x to be 3. So my answer here is 3, 2. Remember, this is in a system of equations. These are 2 lines that might intersect. They happen to intersect at the point 3, 2, so that is my solution. I graphed it on Desmos just to check, and here's the point 3, 2, where they do, in fact, cross. I would like you to pause and try this. And now we'll try it together. So the first thing I notice is I have an equation with a 2x and a y and a negative 3x and a 6. So I probably want to solve this equation for y just because it doesn't have a coefficient in front. So I'm going to subtract 2x from both sides, and I get y equals negative 2x plus 5. So now I'm going to take this and I'm going to plug it into this y with parentheses. So I get negative 3x plus 6, plug in my y, and finish off the equation. Now I have an equation with just x's, so I'm going to go ahead and solve that. I'm going to make sure I distribute, so I get negative 12x plus 30 equals 0. Negative 15x plus 30 equals 0. I'm going to add the 15x over, so I get 30 equals 15x. Make sure you're dividing the right way. Divide by 15, and x equals 2. Part of my solution. You can plug it back into either equation. I'm going to go into the first equation. So I have 2, plug in my 2, plus y equals 5. 4 plus y equals 5, subtract 4, and I get y to be 1. So my answer is 2, 1, which I can see in the graph right there. How'd you do? I hope you got it. Let's look at this one. We're going to try to solve this one using substitution. I'd like you to hit pause and try. what happened. All right, so let's try it together. I do notice that my first equation's already solved for y, so I'm going to take this and I'm going to plug it in here. So I have 4, and then plug in my y equals for y. An equation with all x's, so I'm going to distribute, and I get 12x plus 4 equals 12x plus 3. It seems a little funny when I look at it because it doesn't seem balanced. I can't add 4 to something and 3 to something and get the same thing. But let's try. Let's subtract 12x from both sides, and I get a statement that says 4 equals 3. Did you get that? That doesn't make sense. So when you get a false statement like 4 equals 3, that means that the lines are parallel, so there's no solution. It's a little hard to tell on this one because one of the y-intercepts is 1 and one of them is 3/4. So they're very close, but they are two different lines. They will never intersect. So no solution. Make sure you tell me that. Don't just leave it empty, and don't just leave it at 4 equals 3. Let's try this one. Pause it and give it a try. What happened here? Interesting. All right, so I'm going to use substitution. So I'm going to solve my first one for y. I'm going to subtract 2x over. And now I'm going to plug that into this one. So I get 4x plus 2 times my other grouping. I didn't change that to red. I distribute, and I get 4x minus 4x plus 14 equals 14. Well, 4x minus 14 is 0, and I end up with this 14 equals 14, which is a true statement. So when you get a true statement, it means you're going to have many solutions. So make sure you write many. When you graph it, you can see what happens is you must have had the same slope and the same y-intercept. So we get those coincident lines with many solutions. So let's recap in your notes. When we're solving using substitution, you want to solve one equation for one variable, plug it into the other equation and solve, plug your answer into an equation and solve, then write that answer as a point. If you get a false statement, there's no solution. If you get a true statement, there's many solutions.